Welcome to today's webinar. The topic today is modeling and design of frame structures in RFEM 6 using building model add-on. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, customer projects, and so on. I've been working for the company Dlubal Software for 13 years now. I will be the moderator today and will answer your questions, and my two colleagues will do the presentation. And they can introduce themselves.
All right, thank you. My name is Bastian Kuhn. I'm working in the company since 16 years now. I am dealing with the customer support and design development of timber related points, and also the building model add-on, what we will show you today.
Yeah, hello everyone. My name is Paul Kiedoch. I'm working since almost 12 years at Dlubal Software. I'm working in the product engineering for the concrete design add-on and also with the customer support. And today I'm looking forward to show you the features in context of the building model and the concrete design add-on.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. I say something about the questions. You can ask questions via the control panel on the right side of your screen. You can show that panel with that arrow here and then enter the question here. Me and my colleagues will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, Bastian will start the presentation. He will model a building of the building class 5. You can see that in the preview. He will define stiffening walls and will do the calculation. Then he takes over to Paul, and Paul will design concrete components such as a slab and a wall. Okay, then I hand over the screen to Bastian. Bastian, it's your turn.
Okay, thank you. Okay, Andreas said it already. I will do the modeling stuff. Basically, for this, I will define a new model with the add-ons, what we will need today. That's the building model, the multi-layer surface. We will have a hybrid building made from concrete and timber. Therefore, I'm also activating the concrete and the timber design. But Paul will do the design process afterwards. So it's just for the sake of completeness, or we can actually stay with the Zen today. So we have the standards available here for concrete and timber, and also the combination for this. Then I will at first define the ceiling made from concrete from the building that you just saw in the presentation from Andreas. I will not define thickness, materials, and cross sections on detail, as there are other webinars dealing with this. At first, I'm using a surface 30 centimeters thickness with a C30-37 concrete material. It will be in the XY area with the dimension of 9 and 20 meters. Then for my purlins or the columns in the structure, I will divide the line here for arranging them by 2, and I will copy this for the other columns in the X direction 4 times by 4 meter in, as I said, X direction. Okay, that was wrong. Sorry, I had to press the control button, otherwise it will not work. Okay, so I will repeat this step, and now it looks better. I will do the stiffening of the structure by a so-called concrete kernel, which will be arranged from these nodes that are highlighted in here, and therefore I will delete the 2 nodes there in the front. For the first story should have a height of 3 meters. Therefore, I'm defining this 3 meters here, and I will now switch off the surface and the lines from displaying, and will copy those existing nodes 1 time, also in 3 meters, but I will automatically arrange the columns in between this. Therefore, I'm activating step links in here and define the cross section. The section will have the dimension 40 by 40 centimeters and the same material as the first floor ceiling, but it is a new material. Oh, I forget the reinforcement, sorry. Happened to me twice now. Therefore, I go into the material database. Yeah, now you have that here, and I'm choosing reinforcing steel. Again, that's only for the design process, so not so essential now for the things that I want to show you in the first point, but it's important for the points that Paul will show you. Okay, now I can put the members and the surfaces back again. In this area, that's what I told you, where I want to have the concrete kernel. And now I'm arranging this, and it should have also the same thickness as the ceiling, but once again with a new material. So I have 3 materials already consisting of the same grade. It just makes life a little bit easier afterwards. Okay, so here is the concrete kernel, and that's actually how the majority of the stories should look like. I want to have an opening in this point here, therefore I'm dividing this line by 2 intermediate nodes and give it the first one an X coordinate of 9 meter and the second one an X coordinate of 11 meter. So I have quite a wide opening of 2 meters, which should be enough. That I will also copy by an amount of minus 2.5 meters. And I will not copy anything inside that. So just a node, and define the opening in here. All right. Okay, so now that's done. You probably saw that here are some kind of cells generated. That is something what is already needed for the building model add-on afterwards. And in order to arrange the cells correctly here on the opening, I need to divide this surface. Let me check the number. The surface number 5 by vertical lines completely. And now I could copy the node, of course, just 50 centimeters above, but there's an easier function to use the object snap with perpendicular inside here. And once I activated that, it's generating the line perpendicular to the existing one, and that fits, so that just goes a little bit quicker. All right, so we need supports. That what is missing right now. The bottom columns are from concrete, and therefore I can also clamp the supports. Okay, we can arrange it maybe this way and this way, whatever. So we need to delete those. Those are not sensible in here. Maybe they are a little bit small, so I can use the slide to increase the size a little bit. All right. And now in the concrete kernel, I will also define line supports for the walls. They will be arranged local with a fixed movement in X and Z direction. So they only can bear force in horizontal direction of the wall and in vertical direction of the wall. Okay, so that is the first story, and it's good to go, I say. And then we will copy this one 4 times. Again, 4 times by an amount of -3 meters. Then the building is already there. But we miss one story. And I want to show you that with this add-on, we are able to calculate also unsymmetric ground floor plans. So therefore, I'm defining the top story with a slightly different height. Let's say we want to be very economic, and therefore we just say the top 2 stories should have a node of, or a height of 2.75 meter, which will be round about this, but minus makes more sense. So, all right. Okay, so yeah, it's quite narrow here, but it's still enough, I would say. I also said that we want a hybrid building, therefore the columns in the other stories should be made from timber, except those 2 ones in the back. So we will change them now by members edit and give them a new section in here. So a section of 22 centimeter by 22 centimeter. And of course, oops, that was wrong, sorry. A timber material. Therefore, we go into the material database. Now you have that there. And I'm choosing a quite interesting product called Baubuche, which is perfect for designing columns in higher building, as it is light, but can keep the same or nearly the same amount of pressure than concrete can bear. So that's something perfect to be used for high-rise buildings together with timber. Okay, the design types, configurations, and so on, that will be shown to you by Paul for the concrete, and it's the same for concrete, steel, and timber anyway, so we do not have to go too much into detail. The only thing that I can say now, that for the design types, we are assigning a service class 1 for the columns, as they are covered, or they are all inside the building. That's why we are using it this way. Okay, this, and then this columns here, they should have hinges. I'm explaining afterwards why I only assign hinges in those stories after I have assigned or defined the building model data of it. All right, so that's UX, and we do the same for top and bottom. All right, so that's here. We also want the top floor to be a little bit different. Therefore, we will delete this in here and now define cross-laminated timber for the top 2 stories of the structure. Therefore, we define a new thickness. As I had activated the multi-layer add-on, the thickness type layers is available in here. And there's another webinar, probably Andreas will show that to you afterwards, or show you all the webinars, which is dealing with this. Just as a basic information, you can define several layers of material in here. And to make it now quick and simple, or to keep it simple, I'm just choosing a material from the database, but user-defined definition is also possible. There are factors that you can see here that once again are also explained in these other points. Okay, that's the same as what I already showed for the beams. Okay, so then where do we want to have our surface in here? So from this origin, oops, that was wrong. So from this column here to this, and also from this to this. All right, and we do the same in here. On the other side, we could have also mirrored it, then it would have been even quicker for modeling it. Okay, now we have quite a bigger overhang here, and we have also no stiffness in here. What do we do there? Well, for sure, we will need some beam there. That's going to be a new member and also a new section. We will choose the section 18 centimeters by 22 made from glulam. All right, member, and then we have it in here. There's something that has not been divided correctly. I will do so now. Yeah, looks good. Okay, there was something that looks strange to me. Okay, so that we have, I forgot to assign there also the moment hinges. I can add that quickly by just selecting here the hinges and choose the same ones as for the columns. And for sure, those have to be eccentric. That can also be added here. So eccentricity, and we will have it underneath with an offset to the existing surface, and it's going to be this one. And all right. Oh, that was too quick. We need it also on both sides of the member. Okay, that looks good. I say, yeah, looks good. Now, when you have a downstand beam under a ceiling, and also here the CLT plate should be connected with some kind of slip or degree of freedom, as a moment stiff rotation is not possible for timber in here. Therefore, we will insert type for lines, line hinges, dialog box. I'm once again not explaining that in detail, but there should also be a slip in UX direction, but we will skip that and just use the moment-free rotation today on this surface. Okay, I hope I got them all. We can take a look. It's a little bit small in the displaying, but we can use the slide again to make that bigger. Looks good. So we have defined some degree of freedom in here. Okay, that is it. Okay, but we need also the last story of this. Therefore, we will, this one here we can delete, and we will copy this just by a value of 1 in x direction minus 2.75 meter. All right. And in here, we don't, just to have it quite unsymmetric, we have that in here. All right. Okay, here is open. Maybe we can also add a little concrete cover there on top. Therefore, we choose the first material. Okay, so that looks better. Go into the rendering, and now I think everybody can understand how this building is supposed to work. Okay, loading, we need to assign. So, but before we do that, we define all the load cases. So we have the live load, and then we have snow below 1,000 meters, and we also will define wind just to have something. Okay, and now the first load case should have, just let me take a look at my documents, should have an amount of 1 kilonewton per square meter. So I'm choosing this here. I only have to do that for the first load case. For the second, I can actually copy those from here. So apply and next, and you see it in the back. There it is. And then we do the same for the second load case with another value. Apply and next. And now for the snow, we just pick the roof. Oh, and a different value of 0.85. Okay, that's the load. We will also use the load wizard for the wind load. We have the same for the snow load, but we simplified it a little bit here. We can choose the base corners for the wind load, and now also the roof. Zack. Okay. We will just assign the wind load on front of the building, just on the weak side. So that should actually be the design giving value in here. We are choosing category 0, does not really matter too much, and let the wind load generator generate the wind load on it. So if we move to load case 4, you can see that horizontal load is assigned onto the building. Okay, so I forgot load cases and combinations. Okay, we can keep a small eye on this. Design situation, I'm just designing ultimate limit state. In here, according the first order theory, and let the program calculate my combinations. And now if we look, for example, for the combination 12 and the results, what we have in combination 12, you see there's a one-time calculation done for this building. And now without the building model add-on, it's possible for sure, because we also do that in a lot of other webinars to design it. But you see that you have now mixed the inner forces of the walls. Let's say we go for internal forces moment X. So you have the ceilings in here and also the walls, and you have mixed that all, and you have no clear way to separate between walls and ceilings in here. And that is now something where the building model add-on can help you. Therefore, as we have activated the building model add-on, we will assign building stories. So we got inside in here and define new building stories. There are several ways to generate also stories in here, but the usual way probably is to design a building and then assign the stories to it. And that's what I'm showing you here today. The other ways are all described in the manual. Okay, first elevation is -3 meters. And now we can more or less automatically arrange all the other stories. You see now that the 5th floor has a different Z coordinate. I need to pick it again in here. And yeah, then use the last floor more or less automatically. Okay, this I can do, or this I've done now. And for the story 0 to 3, I'm choosing the floor modeling rigid diaphragm. There's also an object load transfer only, but I'm not explaining this today. Load transfer, just as a short explanation, is a kind of surface that is only distributing load. If I should have done the load assigning correctly for the snow, there where you see the holes in here, maybe you already realized that, I should have assigned a load transfer surface, but yeah, for this webinar, I did not model it or use it today. Okay, so for this stories you see in here, I'm assigning rigid diaphragm. And now when you press OK, it's deleting all the results. And now you see here a lot of red lines, I would say. These are rigid couplings which go from, and you see a blue bubble in here. So the lightest one is on the top story to 28.59 something tons. And then, okay, concrete is the heavier material. It goes up the more down you go. And these red lines, or these rigid couplings, are centered in this mass center, and they are connected to each of the columns or each FE element in each story. Maybe we take just a look on one story. Therefore, we will use story 3, for example. Visibility by selected and related objects. It should give it to us. I think it's not nice. Hold on. Yeah, maybe we just use this one story here. Yeah, that's what I want. So you see they are centered all in here. There are the surface cells. They are only on this smaller objects in here. And now each of this point is connected rigid with the center. Not complete rigid, as the ends of this rigid have a moment hinge, and that's also the reason why I did not define moment hinges on the columns in here, as the ceiling itself is considered as a ceiling. It may sound a little bit stupid, but that's an important point. Yeah, that's the first change what we have from this. Now, what else do we do with the building model add-on before we calculate the building? We can define, if you look down here, floor sets. That's already done, as I had defined it in the building stories, but I can just take a quick look to this. There you see that each of the ceilings or the surface there has now a floor set. If we double click onto the surface, oops, sorry, that was wrong. That's not what I wanted. I wanted to click on the surface here. Paul will show that to you afterwards for the concrete design, as this is the main point with it, what you can do. But you see that originally there was a surface, a standard surface thickness type. And now it is overwritten by the building model add-on with floor slab rigid diaphragm. So this is all organized here, and now we can define shear walls. Shear walls, yeah, I don't think I need to explain what shear walls are. They are in the concrete kernel in here. So at first I'm using the one in the rear. Oops, come on. So there's none here. Then you cannot pick it. All right. Should have switched on the rendering, because now you can see what it's doing there. It's generating a section that goes from the first story to the fourth story. And I'm doing the same for the sides, as those buildings or those walls are going from the first to the fifth story. Choop and choop. All right. Okay. And okay, and then also the opposite side, I'm doing the same. Okay. Okay. Oops. All right. Okay. Yeah, once again, okay. Okay, okay. And maybe I can switch off the rigid links. Just looks a little bit better in my opinion. Okay, now that's all assigned. It's automatic generated result beams that Paul will design. And now when we calculate the design situation 1, so we press calculation in here. And if you look for the calculation progress, here now the mesh is generated. But now you see combination 1, combination 1, combination 1. First entry is combination 1 static analysis. Second is combination 1 floor stiffness calculation. And third is rigidity. So every combination that we have, 13 by its number, is calculated now 3 times. What's the reason for this? The reason is that in the building model add-on, and we watched the combination 12 before, there you saw that we only have static analysis. So we still have the original one, what you have without the building model, but we have 2 more calculations that it's doing. And that's where the building model add-on helps you to show or not show results, basically. So if you look for the design situation, you see in a static analysis absolutely no difference to what we have before. The problematic, what I just mentioned when we looked at combination 12, it's all there. So there's not really a benefit of it. But if you look for the combination 12 again now, so we click on this here, you have a new entry, analysis of building stories. And now it's separated. You see the main point, which is more or less my shear walls or the shear wall design that I have in here. And those can now be calculated, for example, in the timber design or in the concrete design add-on. The second one is the floors only. So you see, even though those floor stiffness is overwritten by rigid diaphragm, you still have a vertical bending, which you would not have with only rigid diaphragm. So in the vertical direction, we are using the stiffness of the usual surface. So for horizontal, we are deformation for the stiffness of the structure in horizontal direction. We are using the rigid diaphragm stiffness, but for vertical, the original stiffness is done. That's why these 3 design rows, I don't know if that's the right word, or times are done in here. Okay, and the combination, that's then still again the original point what we have. I have explained the following in the previous webinar of the building model, but just to have mentioned all the options from the building model, I also want to show you the results by stories here in the static analysis. You see, you have a location of a resultant story force. You have the story forces, and you see we only have assigned horizontal force in y direction. That's why we only have story forces in y direction. Well, the difference between the interstory drift is the same, and the same reason also, because I assigned the load only in this one direction. And additionally to the center of mass in here, yeah, that's where I look for it, we also have a center of rigidity. Let me take a look. It should be, it should actually be in here. Wait, we can just switch off this result. And maybe we can not display the, where is the building model? There. The center of gravity and my center, it should be a little bit different in here. Description. I had found it before, but not yet. I have to look for it. Surface cells, surface releases. No, not yet. But you can display it. Display it currently. Oh, elevation mass. No, I apologize. I will give the word to Paul and take a look where it is, and then hopefully when he has finished his presentation, you can, or maybe he already knows and can show it. Otherwise, I will show that to you after he has done his presentation. Okay, Paul, it's your turn for designing the elements that I created.
Thanks, Bastian. So you can hand over the screen to me.
All right.
Okay. So you should now see my screen, I guess. Just check it. Yes, perfect. So Bastian has modeled the structure and has also done the entries in the building model. And now I will continue with the design in the concrete design add-on. Before I start with that, I will just lose some words about the changes on my file compared to the last state of Bastian. I have just added some combinations here with characteristic design situations and quasi-permanent design situation, just for being able to perform the serviceability limit state design checks in the concrete design add-on. So that is a change compared to Bastian's latest state. And I have also assigned here some mesh refinements, nodal mesh refinements, and surface result adjustments. But that are basic functions from RFEM 6, so I will not deal with that today. I will directly concentrate on the features of the building model and the combination with the concrete design add-on. So I would like to start with the shear walls at first. So at first I will explain to you the context of designing shear walls in concrete design add-on that were generated by the building model add-on. Bastian has entered here this shear walls on this exterior wall here, and he has just selected, for example, one surface. If I would, or like he has done, just select one surface, then the program would generate us a rectangular section, like in this case, and it will automatically create a member type result beam. In the current development state, we are able in the concrete design add-on to design this section. So to enter the reinforcement for this rectangle section, and then afterwards to perform the design checks. Of course, you may be asked yourself, why haven't we selected also the combination of this wall, and this wall? So maybe you would expect a shear wall, with a member with a section of C shape or L shape, like I would have selected just these two surfaces. That will be possible in the future. But in this case, if you would assign, let's say, these three walls, the program would generate a section with a C shape, and then it would not be a rectangle section, like in this case, but it would be a C shape R section. So then you would get here the wording R section, and what we are still in development is an interface of RFEM 6 and our cross-section program R section. And in the future, it will be possible also to reinforce such cross sections with an L shape, T shape, or C shape in our section, define the reinforcement in our section, and then import it back to RFEM 6 and do the design here in the concrete design add-on. But this interface between the two programs is not ready yet. That's why we have selected for the shear walls just one surface, and we are running the analysis now with regular rectangle cross sections. Just to give you a background why we have selected just the individual surfaces here now and today. So when I want to start the design process of these shear walls, then I can basically select them just with clicked or pressed Control key. Open them, and like I said before, we are getting a result beam here with this rectangle cross section, and like for every other beam that you already know from RFEM 6, you can activate here these design properties. If these design properties were activated, then you get here the tabs for the concrete design add-on. So like, for example, the concrete effective length, the concrete covering settings, and of course, shear reinforcement and longitudinal reinforcement. So in my today's example, I would like to apply a shear reinforcement with a diameter of 10 millimeters and a spacing of 15 centimeters. So the program automatically adjusts here the rendering of this member. Then I can click on apply. And then I'm switching over here to this next tab, longitudinal reinforcement. And there I will switch here the rebar type to type D line. And with this type, I would like to apply here a reinforcement on this outer lines of this section. And therefore, I will apply 26 rebars, a number of bars 26. In this example, I'm using a diameter of 12 millimeters. And now with the settings, I have to define on which line of this section these 26 bars should be applied on. So I will use here from left top side to the left bottom side. Okay. Then you see here already on this left side of this section, these 26 bars. And what I also will apply here is the offset here. I would not use 40 millimeters here, but 20 in this example. Just to show you how you can work with this dialog here. Then I click on apply. And now I want to copy this item here to the other side. Therefore, I'm just selecting it here, clicking on copy. And then I'm selecting this second item. And I now have just to switch the reference from the start point. Now it's the right top side. And then on the bottom, it's the right bottom side. And then it looks like this. I click on apply. And now you see here this reinforcement over the height of 4 meters here for this section. Now I would like to show you a new feature which you will get in the next version next week. So I'm working now in an internal version now, and I would like to give you here a short demonstration about a new reinforcement type. It is called cross ties. So since starting with next week, in the new version next week, you can assign cross ties to all of your cross sections. I will show it at first here for this, let's call it wall section. So if you activate this cross ties here, the program will generate these rebars here from one free rebar to another. And you can now with this activated check also deactivate these cross ties that you do not need in your section. So for example, you can go through here and just define that you don't want to apply this cross ties on every rebar here. So you can just click in here. It's a little bit of clicking, I think, for this height of the section, but I decided to do it also for this section just to give you a demonstration how it works. And as I said before, it will be available starting next week with the new customer release. So let's do it in this way. Click on apply. And then I have defined the reinforcement here, including this new type cross ties. If I click on OK, I can control the settings also in the rendering. So therefore, I will switch to the view navigator and just click on here types for concrete design. And then you would see here this reinforcement for this member, including these new cross ties. I will switch this off just because maybe it looks a little bit too confusing if I let it activated. So that are my members for the shear walls. I will afterwards do the calculation only for the new object. So I'm deactivated here the checks for design all, and now I'm selecting just the objects with new features here in context of the building model add-on. So that are our shear walls here. That is okay for the first step. If I'm switching back to the data navigator, then we have here now the shear walls defined. And what you can see here now is a new type, spandrels. And with this type spandrels, you can, or object, you can basically define spandrels or generate spandrels, or also deep beams. We can use for the spandrels the regular surfaces, or like Bastian has generated before, the surface cells. So these are the cells with the blue, light blue out border lines here. Therefore, I'm clicking here and creating a new spandrel, and you see here the options. You can select either a surface or a surface cell for creating a spandrel, and while creating the spandrel, the program will once again create a result beam and create automatically the correct cross section for this result beam, and also assign the correct surfaces to the result beam, so that if you're using the building model add-on, the former process, which you maybe also know from RFEM 5, to create a result beam and create a section for the result beam and assign everything manually, that can be now done automatically by using the features in the building model add-on. So I can select a cell. I'm starting here with this one and clicking on apply, and then you see here the program has automatically created a section for our result beam, and I can just continue, create a new spandrel, selecting the next cell, clicking on OK, then the next one, just zoom in to find the right cell, 19, then the next one, OK, and the last one is this one here. So okay, I have done this now for these horizontal cells here. So I've generated these result beams here by clicking on the cell. Of course, like I said before, you can use the regular slabs, for example, to generate a deep beam by using this object spandrel, or you can also combine multiple cells by clicking multiple cells to generate a larger spandrel. But in our today's example, I have just used the cells upon the openings. So after that spandrels were generated, I will open the first one here. And as shown before for the shear walls, I can activate here the design properties for this object. Once again, I can change here the spacing of the shear reinforcement. And if you now click maybe here, you can see it, like how it looks like. And here we have once again our free rebars. So we can also activate here our new cross ties, but I will at first switch here to this longitudinal reinforcement and change the settings here. I would like to use here uniform surrounding and 8 bars with a diameter of 12 millimeter. I click on apply, and now I have here on each side one free bar where no stirrup was assigned to, so I can go back to shear reinforcement, and now I can also click here on cross ties over free rebars, and then it looks like this. And here now, if this, like I said before, if this option was activated, you can graphically activate and deactivate here these shear links. And these stirrups or cross ties will be considered in the shear force design check and also in the detailing design checks. Because of the fact that we considering this stirrups or cross ties also in the shear and detailing design checks, we have currently implemented this cross ties for the Eurocode, Eurocode 2, including the national annexes. If you would like to use this cross type for the American standard ACI or the Canadian standard CSA, you have to wait a little bit. So we will release this for the other standards also as soon as possible, but next week we will release it at first for the Eurocode. Okay, in my example today, I will not apply them for the calculation. I wanted just to show you here this new option in context of this webinar. Okay, I'm clicking on OK now. And for the other members, we'll select them just by holding the Control key, doing a double click on the selected members, and then I activate once again the design properties. And now I can use this button here to overtake the settings from this member here. And by doing so, we have here this settings regarding the shear reinforcement already done, and also regarding the longitudinal reinforcement. I will just change the amount of longitudinal rebars to 10 rebars with diameter of 12 millimeters. Okay, so I will apply this reinforcement for these spandrels here. So we have now defined our shear walls that are basically result beams. I think in the most cases vertical result beams, and here these spandrels, or let's say maybe also you can maybe call them also deep beams. It's up to you how you use this function. And I guess that these objects will be the most cases horizontal elements. So we have defined them, and I have just to select these rebars now, or these members, to design in the add-on. Okay, confirm that with OK. And here I already have a check if no member number is here in this sales phone not valid or deactivated, then I can be sure that all settings were set up properly for the design in the add-on. So that is already a first check whether all settings are okay. Then I will save this state and go over to the slabs. Like Bastian already said before, if you activate the building model add-on, then there is a new stiffness type for the slabs. The stiffness type is now called floor slab and rigid diaphragm. So that means, like Bastian already said before, the calculation process is done in 2 steps. For the floor slab, basically we perform a 2D calculation for the individual slab. And this, the second step is the calculation as a rigid diaphragm. And in this case, or in this calculation process, the program basically transmits the horizontal loads on the exterior walls into the core of the building. So it's just load transmission, or transmission of horizontal loads. For this 2D calculation of this floor slab, we have, of course, all these already known settings for the concrete design add-on. So like concrete covering, concrete design properties with the reinforcement directions, and surface reinforcement. So now I can set up here for these 4 surfaces a mesh reinforcement, for example. So I can switch the reinforcement type here to mesh, and in my today's example, I will use the German product range and use here this mesh for the calculation. Click on OK and on OK, and then it will be correctly applied here exactly, and I can select these surfaces here for design in the add-on. Okay, so, and to show you the last feature for the building model today, I will also apply two surfaces here that are calculated in the standard approach, I would say, or standard stiffness. So these two surfaces, just randomly picked, these two surfaces do have the well-known stiffness type standard. And I will assign here also a reinforcement, and this time not by using a mesh, but using just the regular rebars here. Confirming that and confirming that once again. And then I will select these two slabs here also for the design. Okay, then I will save this. And with these settings, I think that everything was set up correctly. So I can start now the calculation, and the program will do the calculation for all of our load combination in the same way like before with this static analysis, this regular static analysis calculation, the calculation of the 2D floor slabs and rigidity to transmit the horizontal loads into the core of this building. Okay, I'm just waiting until the calculation is done, and then I will go over to the results and show you there the results for these objects from the building model. I guess it will be ready in some seconds. Okay, looks good till now. Okay, then maybe have a little bit to wait until the results will be displayed. That's also in combination with the app for this webinar today. Now we have it. Okay, at first, let's take a look at the result, at the design check details for the members. In general, if you use the objects from the building model add-on, you will get exactly the same results like for regular beams. So, like I said before, the building model add-on is generating result beams, and these result beams are used for the design checks in concrete design add-on. So if we switch over to design ratios on members, then I'm clicking here on, I'm switching to the table design ratios on member, and I'm switching now or selecting now one member like this one here. Then you see that the program would now do the design checks here, especially for the detailing design checks, according to chapter 9.5. So that means the program would recognize this member as a column. So currently, like I said before, the program is calculating these result beams like regular beams, and in this case, the program would recognize this object as a column. If I'm clicking on a beam like this one here, then we have these design checks here, and there you see the detailing design checks according to chapter 9.2, though here we have the design checks, detailing design checks for a regular beam. That is currently some kind of intermediate state. We are planning to extend the possibilities for this add-on in the future. So there will be an option here to design also directly here new object types, shear walls and spandrels or deep beams. So if these member objects will be separated into these regular members and members for shear walls and members for spandrels. Then we will also implement the detailing design checks for deep beams and walls according chapter 9.6 and 9.7 of the Eurocode as well. Currently, it's not implemented, so currently the program would do this design checks like for regular beams. One last change here in the concrete design add-on, if you are working with this floor slab rigid diaphragm stiffness type, is regarding the results. So if we switch over here, and I'm going to the design check on the surfaces, then in the first step, it looks like always, so regular results. We have here these design checks on the surfaces, and then, for example, here ultimate limit state, and then you can check the design checks, for example, for direction 1 on the bottom side. Maybe look like this. And now if you open here this little arrow, then you get here new results. So this one is already known here. That is basically the required reinforcement or determined reinforcement. And now this is a new option here. And this comes directly from this calculation with the building model add-on. So we have now here inside a 3D object or 3D structure, a separation between design membrane forces and design moments. So for these regular walls here on this end, that's why I've selected randomly these two slabs here. We have this regular design membrane forces. So it's like you would design regular 3D objects. And this new setting here in context of a 3D file is the design moment. And you see here these design moments are coming from the approach that these slabs here with this stiffness type, just click on it, double stiffness type, floor slab rigid diaphragms, are now calculated like a 2D object inside a 3D structure. So basically, it's the same like you would do the calculation here by using this type of model 2D plate, but inside of a 3D building. So that is the benefit of using the building model add-on. So you can now do the 2D calculation of individual slabs inside a 3D structure. That's all from my point today. And now I think that Bastian had one topic left. I think I can.
But you don't have to hand over the screen to me. You just, if you may activate the static analysis in the navigator results, we can do it together. I just found it. Yeah, I looked at the wrong spot and just changed from design situation to any kind of load combination. Oh. Then you see it on the bottom there in the navigator. It's center of rigidity. On the bottom.
Here it is.
There it is.
That's what. That's
and then
what.
If you just there you see the blue nodes, bubbles. Maybe if you switch off surfaces. Results.
Okay. Then you don't see it. It's a part of the results. So you see here this blue light blue bubbles, I guess.
Yes, there is. Yeah.
Okay.
Okay.
Then this is also cleared up, and I can hand over the screen to Andreas, I think.
Yes, I just answered the question. Yeah, the question was if the attendees get a certificate. Yes, you will get the certificate in the next days. You will get a link to the recording of the webinar. I will show that on the website. At first, thank you to my both colleagues for the nice presentations. The attendees could see how powerful the add-on building model is. You can combine it with other add-ons and so on. Yeah, thank you. So I hand over this, or take over the screen, just a moment. If you want to book your free online appointment, such as a product demonstration, you just contact our sales team with that link here, or you can scan the QR code. You can get non-binding offer if you want to have it for the programs or the add-ons. Just contact our sales team. So then I show the website, dlubal.com, under news and events. Then you can go down to the webinars. At first, I would like to show you what we present the next weeks. Next week, I will present an introduction to RFEM 6 and RSTAB 9. It's perfect for beginners of RFEM 6 and RSTAB 9. It's divided in two parts. The week after next week, there's part 2 with the combinatorics, design, documentation, and so on. And the first part, I will show the modeling and load input and so on. So let's search for today's webinar. That's today's webinar. It's already a previous webinar on our website. You will get, as I mentioned, you will get an email in the next days where you can find the link to that page here. You will find the recording here. The certificate is included in the mail. Then you already find the presentation slides here with the link to when you want to contact our sales team. And you can find the model already here. Okay, that should be also all from my side. Thank you for your attention. I hope we meet each other in future webinars. We present webinars every week. Thank you to my colleagues for the nice presentations. I wish all a nice rest of the day. Bye-bye.
Ciao.